Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is the result of a conversation we had on the channel on the previous video, the one about debuggers. Should you avoid debuggers? And as you can see, this is one of the perks of being part of this channel. If you write a comment, you might see a video that talks or answers that comment. And the question that we will try to answer today is, should you really use debug asserts? Are debug asserts useful? It's kind of a continuation to the debugging conversation, but as you'll see, we'll also get into more details. There are some very interesting things coming up. First of all, as usual, let's just skip to the conclusions. And the conclusions are that debug asserts are a very useful tool for temporary debugging code. I often find myself in the situation when even if I have tests, a test would fail for weird reasons, and then I can add a debug assert and I would get more information about what's going on. But what I usually do is I delete that debug assert very quickly, and then I change the test or adjust the design accordingly. Because I have a problem, and I think that's the biggest problem with debug asserts, they have unclear intent. The question you are always asking about debug asserts: what are we checking? Why are we checking? And how do we use them in a way that is structured and that makes sense? And I think, and this is what we'll discuss, there are a few better ways. One of them is design by contract, which is fundamentally taking the idea of debug asserts to the next level and making it structured and disciplined. Guard clauses and automated tests. And in case you are working on legacy code where it's more difficult to add tests, which is something we discussed on this channel before, consider using a few things that have come up or that maybe you don't know that are very useful. The nullable testing patterns by James Shore, or the spy probe pattern, which basically means injecting an object into a function and capturing data from that function, and that you can check in automated tests. So that's basically debug asserts, but at test time. With this being said, if this answers your question, great. If not, well, we have a lot more to talk about because there are some very interesting things related to debug asserts. And we'll first talk about what are debug asserts, just to make sure that we understand the same things. Then talk about design by contract, the problem of unclear intent, debug asserts versus tests. And let's start by asking this question: what are debug asserts? So a debug assert is fundamentally an assertion that is applied at debug time. Nothing surprising here, right? It's very clear. If you are in debug mode, you're running your program in debug mode, and the assertion fails, it usually throws an exception. And in release mode, it just doesn't run, so it's completely ignored. This is an example of conditional debugging, because the assert is basically not included at all into the release mode. At least this was the implementation in C++. I think in C# or Java they are included in the end product, but they are just disabled. But in C++ you have this advantage that you have conditional compilation. But I'm actually not sure. It might be that even in C# and Java, the implementation of the function is actually such that it's completely ignored in when you compile it for release mode. And this leads to the first issue with debug asserts. They are a way of doing conditional compilation, and conditional compilation is kind of complicated. It's not the cleanest way of dealing with things. Now, I understand why conditional compilation is used, particularly in systems programming and particularly when you are targeting multiple platforms. In C++, the way you target traditionally multiple platforms is have include files that include different things depending on the operating system and on the version of the operating system and so on. Because things change, so you need to target them differently. However, I never found this as the cleanest way of doing things. I'd rather have subsystems. I would have, for example, a subsystem for Windows 10, a subsystem for Windows 7, a subsystem for macOS, a subsystem for Linux, and these are the ones that are used depending on runtime checks. So, yeah. However, this increases the size of the executable, and this can be a concern sometimes, but it's not a concern all the time. I'd rather have this because I find it much cleaner in this way than with conditional compilation and includes. So debug asserts have shared the same problem. It's conditional compilation, it adds an extra layer of complexity. You need to think of more things, but let's say that programmers are very familiar with debug asserts. It tends to be something that's very used, commonly used. So we can safely bet that programmers are they are familiar with this construct, and it's not a problem for them. It's just automatic. They look at the debug asserts, they understand what they are, they understand they don't run in release mode, so it's not a big issue. But we will see that debug asserts have a problem of intent. And because of this, I'd like first to show you how you could use asserts in a program, but in a very structured and disciplined way. And that way is called design by contract. Design by contract is a method to ensure program correctness created by Bertrand Meyer. And it was implemented in the FL programming language. If you try FL, it has, well, the last time I tried it, it was a long time ago. These asserts that we'll be talking about, these checks, were first-class citizens, and you had to use them. So for each function, there are three types of assertions. There's a precondition, checks applied on the input and on the state before you run the function. This is kind of like validations before running a function. You check all the arguments that they are valid. You would also check the current state of the object. FL is an object-oriented language. So you check the current state of the object and see whether it's okay to run the function at that point in time. So for example, verifying arguments is something that's obvious, but about the state, let's say you have you need to have a file open before you can call a method that reads from the file. And the way you would do that is you'd have a precondition that checks that that file is open. Of course, there are various ways of implementing this, but this is just a basic example. Post conditions, these are checks that are applied on the output and on the state after running the function. So what you expect to happen after you run the function. On the output, for example, you might expect that the output is not null or that it is within specific values or something like that. Let's assume you are returning an enum. Again, a very simple example. If you are returning an enum and the enum can have 10 values, but for this function you can only return 2 of those 10 values. Only those 2 make sense. In your post condition, you check that only one of these 2 enum values was returned, right? So that not any of the others were returned. And about the state, if you continue the example with the file, let's say that after reading the file, you want to close the file, or maybe you want the file to be left open. You could have a post condition that checks this. Say at the end of this function, the file is still open, or this function has closed the file. So these are a few examples of post conditions. Invariants, these are checks applied on things that should not change while running the function. Let's assume you have an object that has multiple data members, let's say 5 data members, but when you call a specific method, it reads 1 data member from that file. So it's okay to change that data member, but it's not okay to change any of the other data members. And this would be an invariant. Another example of invariant is that you have not changed the value of any argument by the end of the function. This is particularly important for reference types. If you are passing something by reference, that you are not changing the value, or pointers or things like that. So the way you do this in Design by Contract is you look at every function, you identify precondition, postcondition, invariants, you implement those, and the typical way to implement them is through debug asserts in popular programming languages. Although, and that's where the interesting part comes in, the view of Design by Contract is not that these are only for debugging. These checks ensure the program correctness. So actually, the intent of these checks is to be run at release time as well as at debug time. But the way Design by Contract has been usually implemented in programming languages was with debug asserts, which kind of misses the intent. The intent is to ensure correctness of the program, and correctness of the program matters more in release mode than it matters in debug mode. So why would you disable the checks in release mode and only keep them in debug mode? And that's one of the things that I'm talking about when it comes to intent. The intent of debug asserts is very fuzzy. Whenever I go through code and I read debug assert, I wonder, why is this here? It's not always obvious why they are there. And often when it's obvious why they are there, the question is, why are these things not enabled at release, in release mode as well? And we'll talk a little bit about the constraints as well. So in general, Design by Contract provides us a very structured and disciplined way of doing asserts. So this is something, again, it's something that applies for every function. And imagine if you had this for every function. It's very unlikely that you get issues with correctness. And I think this will also eliminate a bunch of security issues as well. Now, of course, you'll make mistakes when writing these assertions. And there are some other limitations. So they are either very difficult to implement in modern programming languages. The way you need to implement, so let's take preconditions are fairly easy, right? You can implement them as asserts at the start of a function. You could also implement them on pre-method call hooks as an attribute. Typically, the way they are implemented is as attributes, although I think there should be a whole separate language for this, or sub-language that allows you to write these checks. Post conditions, you can almost implement them as asserts at the end of the function, where you check the state and you check the return values before you return them. And it's kind of okay. You could also implement them as hooks post method call, which would be nicer, I think. But the biggest problem is with invariants, because how do you check for invariants? Well, the only way you can in modern programming languages is to capture the state of an object and argument values before the method call, and then compare it with the state after the method call. And this already leads to various complications. A better way would be if you could turn certain variables, certain data members const for the duration of that method call, because in that way you'd get an error. But the problem is you'd get a compilation error and not a runtime error if it's the const compilation. Well, it should be const at runtime rather than const at compile time. So yeah, it's a bit difficult to implement unless you have all the mechanisms built in. So the ideal way of doing design by contract, from my point of view, would be if I could have a split view. This is the function. I click on the function and I can see the contract. And the contract is written in a kind of mini language. And the programming language just knows how to run this contract on pre-post conditions and invariants, and does this automatically. And then, of course, the next thing is, what do you do in case of an error? And here you need to have, the easiest thing is to throw an exception. But in release mode, this can lead to a few issues. So you need to have a kind of mechanism for closing things, for wrapping up your program. If you are in the middle of many calls and you have open files and all kinds of things, you need to have a way to dispose of all those handlers and stuff. So this is why the idea is extremely useful. I think it would benefit a lot of programs. I think it would remove a lot of security issues, but I don't think we have the right technology for it right now, unless you are using FL, which, as far as I know, is the only programming language that has this out of the box and as a first class citizen. In the other programming languages, we need to play around with various things, and it's not as great. But this shows us the problem with debug asserts. And the biggest problem that I can see is unclear intent. It's a design problem. When I read through code, I don't understand, as I said, I don't often understand why we have a debug assert. It's either in random places, and in that case is, okay, why? Or it's in places where I would rather have something else, something that's either a test or runs at release, in release mode. But I think there are a few things where it helps. Pinpoint problems in debug mode, although the question is, aren't those problems important enough in release mode? If you find a problem in debug mode, would you want it to be found in release mode as well? It can be a temporary debug mechanism, which is something I am using. But the biggest problem is, I think most debug asserts come either from guidelines that say you need to check things, or they come from debugging sessions where they are left in the code, because they are seen as zero cost, right? That's the thing. For release, they don't take out space in the executable. They are optimized away by the compiler. So you don't have any problems. It is basically similar with a comment, but that is executable only in debug mode. So they seem free, but the problem is they are cluttering the code. So they have a cost. The cost is cluttering the code. And also it's a missed opportunity, because often when we see a debug assert, it's either that we would benefit from a test instead, or that assert should be a check-in release mode as well. And another possible thing we might think about is weeding out potential bugs. You just add checks just in case something happens, for the paranoid. And I can understand that, but why not show this in release mode? Why not think all the way through and say, okay, so if this happens here, we need to throw an exception or we need to return an error code because this might happen. Yeah. So that's the biggest problem. And now there's a downside of having the asserts enabled at release mode. And we've already discussed about this, but let's talk also about the ways to avoid this. There is a few potential issues with debug asserts enabled in release mode. First one is performance. If you have many checks, maybe some of the checks need to look into big data structures, need to loop through those. Yeah, it can be weird. It can be costly in terms of performance. But in this case, you can use tests instead. If you're worried about performance, you put this into a test, and the test will check the same things. Only in the case of a test, you do care about performance, right? But usually these are run on various machines. You can parallelize them, and it doesn't have a performance hit on the actual released product. Error handling. What happens if you have an assert failure at runtime? Well, what I would tell you is you need a clear policy on error handling and logging. And that policy should need to take into account asserts and maybe have a default mechanism that just turns off the program, releases whatever it needs to release, cancels transactions or whatever it needs to do before closing down. Right? But this should be part of your error handling and logging. Now, one advantage of having debug asserts enabled at runtime in release mode is that you'll get a much better way to pinpoint where the error lies, where it originated. And think about the design by contract as well. You will know exactly what function and under which conditions it failed. That's great. It's just, it gives you exactly where to go, what to look for, what conditions to create in order for that bug to be reproduced. So it's incredibly useful for debugging. But yeah, you need to take this into account in your error handling policy. What about tests? Because we talked about maybe you could replace debug asserts with tests. Well, tests provide the same advantages as debug asserts. You can run tests on preconditions, on postconditions, on invariants. Now, is this easy? Not always, right? Preconditions, how do you check for preconditions? Well, you basically try various inputs and you check the outputs. That's fundamentally how tests work. So in case of preconditions, things should fail if you provide an input that is not correct or if the state of the object is not correct. You can write tests that reproduce those states. What about postconditions, where postconditions check the return value and the state of the object? Basically, you pass in inputs, you check on outputs, and you can check the state of the object as well. Pretty clear. Invariants are slightly more difficult because for invariants you need to capture the state of the object before and the state of the object after and compare the two. And that's typically not easy to do with tests, although there are some patterns that you can use in order to do that. But realistically speaking, I've rarely seen tests written on invariants. Okay, you could, but very few people do. Now, I have a mistype here. Tests have none of the disadvantages of debug asserts. Performance and error handling are not an issue for tests. If something fails in a test, that's fine. If you have tests that are checking, various large data structures, that's also fine. May need to parallelize tests to run them on more powerful machines, but it's not a problem in general. It doesn't impact the released product. However, it's more difficult to add tests to legacy code than to add debug asserts. But as we know, it's better on the longer term. So what we are saying here is that in general, it's better to use tests than debug asserts. with a very few exceptions. Okay, let's now talk a little bit about design by contract and tests. In design by contract, the checks that you are adding to each functions are first-class citizens, and they are part of your production code. So they are not really debug asserts, they are both debug and release asserts. They are production code. Because they are production code, so I always had this issue because in my mind, there are two ways of achieving correctness for programs. One of them is design by contract. For every function, you have precondition, postcondition invariance. If you do this right, if you do this disciplined, you will get programs that do what they are supposed to do. They don't necessarily do what the users need them to do, but that's a completely different thing. But in terms of correctness, this is the specification, this is what's implemented, it should pretty much match. The other way is using tests, which is similar, only you tend to separate the test code from the production code. And because of this, you have a slim production code and release product, and you have the tests separate. And the tests basically check similar things. You can also make a model for tests to validate correctness of a program. You have, for each object, you validate two things: that assuming everything around this object works correctly, this object works correctly, and then this object is collaborating correctly with every other object that it interacts with. And based on this, you can create a testing strategy that actually leads you to correctness. There are some issues you need to take into account, like how do you test for, how do you make sure that you test all the possible examples and that you don't miss examples and so on. So there are various things there, but there are methods as well to deal with that. So I always had this dichotomy of, we have these two methods, and what happens if you combine them? Because it's like using tests. Do we write tests? Do we not write tests? How do you use precondition, postcondition invariance with tests? And then I had a conversation with Rebecca Worsbrook, and she told me, well, you write tests. Actually, she said, I write tests for my precondition, postconditions, and invariance. And then, yes, it suddenly made sense to me, because these are part of your production code, so you should test them. So, yeah, you need to write tests for your design by contract as well. Only maybe it's a bit more structured. All right. So if we are talking about how debug asserts don't have a clear intent, what are some of the alternatives? One of them is design by contract, which has a clear intent. The intent is to ensure correctness, and because of this, we enable at release time the same things that we have at debug time. No worries there. Another thing you can use is guard clauses. If your debug asserts are just checking the inputs, why is that not in the released product? Shouldn't you be checking inputs anyway in your production code? So the way to do that is typically with guard clauses. Generally, in the beginning of every function, or before using objects, you would validate the input arguments. And you can also validate the state before using those arguments, and return errors, throw exceptions when something is not right, that depending on your error management policy. And this is by far the clearer way, right? And if you replace your debug asserts with guard clauses, you might be left with a few random debug asserts in your code that were used for debugging. And in that case, the question is, shouldn't you have a guard clause there? Or shouldn't you have a test instead? With the tests having the advantage of actually having a clearer intent. Now, the problem is, if you are working on legacy code, it might be difficult to add these tests. But there are two options here that I won't go into details, but these are two options that you can use relatively easy. They are slightly related. The spy probe testing pattern. So one way to write tests for a function in legacy code is to add a parameter to the function that will capture data at various points in time during the function call and store the data for later checking. And this has to be, well, if you want to optimize for performance, this should be an optional argument. And it's only used by your function if it's passed in. So maybe you'd have a kind of a nullable object pattern, right? By default, it's an implementation that does nothing. But for tests, you can pass in an implementation that actually stores data. And then you can write the test that calls that method, injects the spy or probe, runs the function, and you get details inside your probe, and then you can check what happened in preconditions, postconditions, invariants, basically. You can use the same test pattern. And similar to this is the nullable testing patterns by James Shore, which I believe are extremely helpful for legacy code, because this change very little. It's a very similar approach with the one that I've discussed here, but you kind of mix in the production code a few things that allow you to write tests, and it's very, very useful. We did a whole video on nullable testing patterns, so check that out. I also promised that I will do a series, a code series on nullable testing patterns. Didn't get to it yet. It's slightly more difficult to produce, and we had a lot of other things to work on. So it's coming, but I don't know when. In conclusion, debug asserts, as I said also in the beginning, debug asserts are a very useful tool for temporarily debugging code. Well, I wouldn't stop anybody from adding a debug assert, well, like I wouldn't stop anybody from using a debugger, right? Everything goes. If you have a problem, you don't know where it comes, any way to solve that problem works. The thing is, try not to leave those in the code and replace them with either a test, guard clauses, something that's more permanent and that's also run in the release mode, because That transmits more intent. If you have a debug assert in your code that is like in a random place, at least have a message that clarifies why this happens, why it's left there, what is the reason, what is the intent. And think about this, right? If you are in 9 months and you see a debug assert failure, how would you know what's going on and why? And so on. By the way, debug asserts were very used in MFC. Back when I was doing C++ with Windows. And it was always very annoying because you would get a debug assert, but it wasn't very clear why. And well, often it was a weird thing like, stupid mistake, like you forgot to initialize a handle or something like that, window handle or control handle, and that was okay. But sometimes they were really difficult to understand. So if you have debug asserts, think of the person who will see that debug assert, both in code and in case it fails. So they have unclear intent. The question is, what are we checking? Why are we checking it? Why is it not in a release as well? Sometimes there's a good answer, but the answer would better be in the message or in a comment. Although I prefer removing comments as much as possible. But in this case, it falls into the category of things that are weird in the code and you need to add an additional explanation. So it makes sense to have a comment for this. Better ways: design by contract, guard clauses, automated tests. And if you are working on legacy code, which is, is difficult to add tests on the legacy code, you have these two options: nullable testing patterns or spy probe. Look into those, and those will help you incrementally add tests with minimal changes to your code. And that makes a whole lot of difference. But the interface of your methods will start to look weirder. Okay, you will have additional parameters. So trade-offs, nothing's perfect. You need to have trade-offs between these different approaches depending on what is your context. And that was it from me today. I hope you found this interesting. Personally, I find design by contract to be a very useful intellectual tool. It's very intriguing. It's something that I've used in a couple of projects, but it's not that easy to use in modern languages. So it's a great approach. I wish there was more support in languages to use design by contract out of the box, but apparently no. And because of this, tests have won the battle for correctness. Although I think what we are missing by having only tests and not having contracts is we are leaking a lot of, we are having security issues and stuff like that. Those are things that would be caught by mechanisms inside the production code that check all the time. But yeah, there's a matter of performance, there are many things. However, I can't help but asking, isn't robustness more important than performance? Hardware seems to be evolving quite fast. We can buy more memory. Shouldn't we care more about programs that are being robust instead? But that's a question you need to answer for yourself in your context for your project. Definitely take a look at design by contract. It's a very nice and structured way. And I would definitely advise you to practice design by contract because it's not as easy as it looks at first sight. Right. I hope you enjoyed this, and as you can see, if you write a comment on our channel, you might end up with a video that answers that comment. So make sure you write comments, ask us, tell us what you've discussed about these issues with your colleagues or your community. Let us know. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.